All right, we'll go ahead and clear your desk except for two clean sheets of paper. YouTube, two clean sheets of paper and a pencil. Everything else away, notes away, cheat sheets away, calculators away, old quizzes away. Just two clean sheets of paper and a pencil. All you need out. First and last name to top of your paper along with today's date, which is 9/22/21. 9/22/21, today's date. And you can put for the assignment Rational Roots Quiz 2. Rational Roots Quiz 2. And number down 1 through 16. Once again, remind my YouTube audience, Gavin and Brecken, no pausing of the video or replaying of the video so you don't have a comparative advantage over your classmates. Trust the honor system here, because you're both honorable young men, and we trust you because we have no choice. All right. And God is watching, and He's on my side. Just remember that. All right. Sick of Jesus. All right. I don't know if that might be slightly blasphemous. I don't know. All right. Number down 1 through 16. All right. As a reminder, for some of these, I'll ask you, for instance, what's the square root of 16, and you would put 4. Other times I might say 4 is the square root of what, and you would put 16. Okay, so we're going to be flexible on these. Let's start though with the kind we had yesterday. For number 1, what is the square root of 400? What is the square root of 400? Number 2, I want to know the cube root of 1,000. The cube root of 1,000. And for number 3, the fourth root of 16. The fourth root of 16. Then for number 4, 15 is the square root of what? 15 is the square root of what? Number 5, 2 is the fifth root of what? 2 is the fifth root of what? Number 6, 3 is the cube root of what? 3 is the cube root of what? For number 7, what is the square root of 289? What is the square root of 289? For number 8, what is the cube root of 512? What is the cube root of 512? For number 9, what is the square root of 169? What is the square root of 169? Number 10. 19 is the square root of what? 19 is the square root of what? Number 11. 3 is the fourth root of what? 3 is the fourth root of what? And number 12, 6 is the cube root of what? 6 is the cube root of what number? Number 13. What is the fifth root of 243? What is the fifth root of 243? Number 14. What's the square root of 324? What is the square root of 324? Number 15. What is the cube root of 343? What is the cube root of 343? And number 16. 4 is the cube root of what number? 4 is the cube root of what number? All right, pencils down. Go ahead and pass those in. If you would, please take your homework handouts out. Take your homework handouts out. I'd be prepared for another quiz tomorrow. Since we're not able to grade these in class because of recording, we'll plan to take one tomorrow as well. And for one more of those. But handout out looks something like this, except it should have answers on it now. Get that handout out. At the top, you were reducing radicals. Again, 3 ways in which we reduce radicals. Of course, we want to factor the radicand and take a root of a factor. We want to take roots of denominators, and the entire denominator, not just a part. Or we want to try to get the index smaller by rewriting the radicand as something to a power, and then canceling something out of the index and all the exponents. And that's what we were practicing with on the top section. Then on the lower part, we were adding and subtracting radicals, and we'll get to that here in just a moment. Hold up the handout so that I can see that it is completed. Bueno, all right. And this isn't the old handout, right? This is the new handout. Okay, that's good. All right. So looking at the first one, we have the square root of 147 x to the 5th y squared. And this is about to be a very sad day because I don't think there's chalk. And how did we let me make sure I'm where the camera can see. Let's come over here. The square root of 147. How would I factor that number, Brandon?
I did 4 and 93.
4 and 93? I don't think that's what you did. I think you did 49 and 3.
Yeah.
I'm pretty sure that's what you did. But I can see why you would think 4 and 93. And so you said you could take the square root of the 93. Excuse me. How much you did to me? You could take the square root of the 49 and get 7. Drag this over just a bit. Too far. And you got 7. And of course, we had to leave the square root of the 3. And then when it came to the letters, Brandon, we remember that to take the root of a power, we just divide the exponent by the index. And the index here is an understood 2. And so 2 goes into 5 with, it goes in 2 times with 1 left. 2 goes into 2 with none left. Do we have to write the first powers, class? Nah, we don't have to write that. And there's our answer. How many had this for the first problem? All right, going down the column here, we have the square root of 3 over 20 n to the 5th. And again, the key is you have to take the root of the denominator. But you can't take the square root of 20. So, Audrey, maybe we should change our 20. So instead it says 100. Okay, I like that one. And but we also can't take the square root of n to the 5th because 2 doesn't go evenly into 5. But maybe we could make that an n to the
9.
Can 2 go into 9 evenly? Abby?
What?
Pay attention. She's busy doing her nails and stuff over there. I'm just kidding. So 2 needs to go into 5 evenly, but it can't, right? So I can't take the square root of n to the 5th. So instead we'll make this maybe an n to the 6th, because 2 can go evenly into 6. But we can't just magically change it. We have to do it mathematically change it. So when we mathematically change it, back to Audrey, we would multiply the bottom by
5.
and the top, of course, by
5n.
Also, because what we do to the bottom have to do to the top to get a numerator of
15n.
15n. Now, the numerator, I don't really care about. And it's a good thing I don't, because I can't do anything with the square root of 15n. Though I should at least see if I can reduce it a little bit, but I can't. The important thing, though, Audrey, is I can take the square root of 100n to the 6th to get
10n cubed.
10n cubed. How many had this answer on the second one down? All right, questions on that? All right, let's take a look at the next one down, where we have the 9th root of 27, x to the 6th, y to the 12th. And again, anytime you've got a really big index, which I would say a 9th root's a big index, we haven't memorized any of those roots, the key is to cancel something with the index class and all the exponents. We cancel with the index and good. Michael got it. The rest of you did. Let's try that again. Class, we cancel with the index and There we go. See, I do it the same way every time to try to help them out, but you're the only one smart enough to catch on. Good job, Michael, new teacher's pet. All right, so the problem is 27 is to the first power, and you can cancel nothing with 9, 1, 6, and 12. So the key is generally to rewrite this 27 Genesis. So instead of saying 27, it looks different. 3 cubed. And now I can cancel something, class, with the index and
all the x.
Right, and what cancels here, Genesis?
3.
A 3 to get,
Well, index was 3.
so cube root.
Cube root, and then 3x squared 4.
There we go. But we're not done, Michael. Why not?
Because 3 can go into 4.
Right, so the index can still divide into one of these exponents, so my final answer should say,
Y times the cube root of 3x squared y.
all right, there's our answer. How many have this final answer on that third one down? Anyone leave it this way? All right, again, watch for that chance at the end to try to reduce down. Let's go down the next column here, where we had the cube root of a 128m squared n to the 6th. And sometimes students will say, Mr. Nadaski, how do I know which method I'm supposed to be using? And I say, well, for one thing, you only take the root of a denominator if there's a fraction, right? So that should be a pretty easy one to rule out. This only happens if there's fractions. But what about these two? Well, if it's a big index, you make it smaller. And if it's not a big index, it's all about factoring. This isn't a big index, so of course I'm factoring. And how would I factor 128, Kendall?
64 times 2.
There we go, where I can take the cube root of the 64 to get,
4.
and we'll leave the
2.
inside the
19.
radicand, the cube root of 2. And then we come to the letters, and we ask ourselves, how many times does
3.
go into,
2.
and the answer,
9.
none. So I don't get to pull any m's out, which means
N squared.
stays inside. And then we say, how many times does
3.
go into, and the answer,
2.
with how many left over?
9.
So I don't leave any in. And there's my answer. How many have this on the first one on the second column? Excellent. For the next one, we have the cube root of a 5 over 9x. And if this were a square root, I actually really like the number 9. But it's not a square, it's a cube root. So I don't like the number 9. Instead, I wish, Maddie, that it said 27. And I also don't like the x, because you can't take the cube root of x, but you could take the cube root of x cubed. And then we have to way to make that happen is to multiply top and bottom by 3x squared, so that my numerator becomes a 15x squared. Now I can take the cube root of the denominator, and that is the cube root of 27x cubed. And in the numerator, what do? Just leave the cube root of 15x squared. Can I cancel the 3 with the 15, class? Nope, this is rational, that's irrational. The x with the x, nope, this is in the radical. Now, what if there were, say, a 6 out here, class? Could I cancel?
Yes.
Yeah, because this is rational 6 with rational 3. Those would cancel, but I cannot cancel this 3 with anything inside a radical. How many have this answer on the second column? Questions on that? And the last one that we had was in the top section, was the 4th root of 324. And now you could, I suppose, try to take the root of a factor. And you could actually do that here. But it's a bigger index than I like. I like square roots and cube roots. I don't like 4th roots. Those are big, right? So my preference would be to make the index smaller. How many did try to make the index smaller? How many tried to factor it up? Because it does factor pretty easily, Michael. How would I factor it?
81 times 4.
81 times 4, because we know the 4th root of 81 is
3.
And I could get 3 times the 4th root of 4. But I can still make it smaller. What is 4, class?
2 squared.
2 squared. And if I simply rewrote it as 2 squared, then in my final answer, I could cancel the 4 and 2 to get a 2 and 1 for a final answer of 3 times the square root of 2. That's one way to do it. The other way would be to say, 4th root, that looks big. I don't like big roots. But I know that this is 18 squared. And so I could say the 4th root of 18 squared. And just as we canceled here, I could cancel here. Square root of 18 to the 1st. And then it factors into, class, 9 and 2. Pull out a times the square root of 2. It's just whichever method you see first. How many, regardless of the way you solved it, got 3 times the square root of 2? Anyone leave it as 3 times the 4th root of 4? Anyone leave it as the square root of 18? So we have a mixture of all the different ways in which it could be answered here, I suppose. Questions at all on that last reducing problem? Any questions at all on reducing radicals? Set the handout aside. We'll finish going over it in a moment. We're going to take a quiz first, just over reducing radicals. Of course, adding radicals we just started yesterday. That's not going to be on this quiz, but reducing radicals will be using all 3 methods. So clear your desk except for a clean sheet of paper, pencil, and a calculator. You're welcome to use if it helps you. Sheet of paper, pencil, calculator, everything else away. Don't worry, YouTube students, I am taking the camera off the poster, but I'm also taking the poster down, so you're not at a disadvantage on your in-person classmates. Though they know this so well, they don't need the poster anyway. And just to show how confident I am in their ability, I'm taking it down. I'm just that sure you don't need it. All right, first and last name at the top of your paper along with today's date, which is 9/22/21 still. 9/22/21. And this is quiz 8. Quiz 8. Should pass one back. Very straightforward. Reduce the radicals to the simplest form. Be sure to show your work, okay, to receive partial credit in case you missed something. Any work you show gives me a chance to give you some credit. Use the quiz copy as a cover sheet. You may begin. they're in pain. I hear groanings which ought not be uttered, as the Bible says. Try to tune it out. It's already out of tune, you might as well tune it out. Should I go shoot it?
Yes.
Wonder where it's coming from. Oh my. I don't think you on YouTube can hear it, but there is this strange, I think it's supposed to be song,
Yes, a song.
but it sounds more like a mournful dirge of some kind, like something died, or maybe the song wants to, I don't know. Oh man, slightly painful. Certainly not ideal quizzing conditions. It's coming from above us, but that should be Mrs. Morrison's math class. Surely not. Sure you keep your work covered, as much as you'd like to keep your ears covered. That becomes a habit. We're going to have to provide earplugs. Accused of subjecting our students to torture. That's not acceptable. Today's society. back in the days of teachers hitting kids in the hands with rulers and stuff. But that, I couldn't put it past them, you know, to have noises like that going into the background. But that's what the students would sound like after they got their hands hit by the ruler. Watch, we're going to be making fun of that noise. And I'm going to get up there and Mrs. Morrison's going to be like, so I got this recording of you singing. Suddenly it sounds beautiful, doesn't it?
No.
Okay, be honest, how many of you sing in the shower? Genesis proudly raises her hand. She's like, yeah, but it don't sound like that, Mr. Nadasky. How many of you have family members that sing in the shower? You would never do that, of course, but they would. How many have a family member that thinks he or she can sing in the shower? Noises like that shouldn't happen from a cat, you know? I hate cats. Sorry. We gave you guys a cat. Is it still alive?
It ran off.
It ran
No, Thomas.
I don't know. It's a black and white one.
Yeah, we still have him.
He
He cost us a lot of money.
Oh, sorry.
We got into
He almost got his
fight.
leg amputated.
Oh, lovely.
He's good now though.
It was pretty funny,
He's so sweet.
I'll be honest.
He wandered over to our house before Christmas one year, and we kept him for like a week. Not in our house, but like we would feed him and play with him and stuff. He was a really sweet cat. And then we had to go on vacation. We're like, well, I'm not going to let the cat just starve. He's kind of grown dependent on us. So I was like, gotta find him a good home. And so, yeah, they asked about a cat. And we're like, hey, we've got a cat. You want a cat?
He's killed a couple mouses and snakes.
Mice. Sorry, it's math class. We shouldn't have to worry about that. How are we coming on this quiz, by the way? Busy talking about cats and singing in the shower.
I'm stuck on 2.
2 problems or number 2?
Number 2.
Oh.
Easy now. It's rude. Yeah, easy.
Not allowed to give any information to people watching on YouTube. Or they probably muted it by now. I should have just stopped the recording when we started the quiz. But I know it would start singing. Wherever it is. I point up, but no, surely not.
They're gone, aren't they?
That's like 2 rooms down, though. They should be at lunch right now.
Yeah, they're gone.
But it's definitely not next door. That would be a lot louder if it were next door.
Maybe.
Aren't you glad it's not louder? Oh. It's just, normally I'd be calling time, but after all of this, I have a really hard time saying, all right, time to turn those in. All right, we're going to be really quiet for 2 minutes, and then I'm going to collect them, okay? Quiet mouse. Quiet mouses. Shh. I can't, I'm sorry. I tried. If only you folks on YouTube could hear it. Sometimes you worry about people singing because you're like, YouTube will ding you for a copyright infringement. You know, that comes copyrighted. You can't have it on your YouTube video. That song, whatever it was, YouTube wouldn't detect any copyright infringement. Even if it is copyrighted, they wouldn't be able to tell. They might flag it for not reaching community standards.
I think we'll stop.
Y'all laugh too much.
For real, this is school. We're not supposed to be having fun right now. School is miserable. Let's get it together. Frowny faces. Frowny faces, everyone. Be sad. That started. Genesis, the quicker you finish, the quicker I can start teaching and you won't have to listen to it.
It's quite pleasant. Sounded like Maddie. She got her southern
That's
accent.
your mom. Not the one singing.
Maybe.
No.
No, out in the hall. Okay.
That's probably Peter.
All right, let's go and collect those, and let's get into our lesson. And you can listen to me instead of that. Well, never mind. Everyone needs more time on their quiz now. All right, next section, your notes. Actually, no, handouts back out. Excuse me. I'm all set to get teaching again. We got to finish going over the homework. Talked to you yesterday. If somehow you on YouTube are not done yet, pause the video. We're rolling. We talked yesterday about adding, subtracting radicals, and we said you can only add or subtract radicals, class, that are similar, like to each other is another acceptable term for it. And we said two things have to be true for radicals to be similar. First of all, Maddie, they have to have the same index, and they almost also have, Audrey, the same radicand. Same index, same radicand. Really, the only thing that can be different is the coefficients of the radicals for them to be similar. And if they're similar, you can add them, you can subtract them, but you leave the radical alone. You reduce at the beginning to get them similar. Then you leave the radical alone, you just add and subtract coefficients. That's different than what we're going to get to today. Let's take a look at the handout. And we had the square root, or 2 times the square root of 250, plus 3 times the 4th root of 49, plus the square root of 128, minus 20 times the square root of 2/5. And again, obviously none of these are similar to each other right now, though I will say at least 3 of them all have the same index. There's one of them that kind of catches my attention because it don't have the same index as any of them, right? So I'd probably start here, and what ought we do, Kendall?
To reduce,
Right, by doing what?
rewriting 49 and 7 squared.
All right, let's rewrite this as the 4th root of 7 squared so that we can then reduce it down to,
3 times the square root of 7.
there we go, reduce to get a 2 and a 1, so 3 times the square root of 7. So at least now they're all square roots, right? Though now my attention kind of drifts over this guy, I'm like, that's just ugly, right? I mean, you got this big old fraction nonsense, so we got to take the root class of the, did I copy something wrong?
It's negative.
Oh, -3, thank you. Okay.
We don't need a apostrophe in our life.
There we go. All right, so Brandon, Mr. Negative, let's come back over here. We have to take the root of the denominator, but you can't take the square root of 5, so we're going to change the fraction and make it 25 in the bottom, so 10 at the top. At the same time, I recommended you do what with the coefficient, class?
Put it over 1.
Put it over 1. Turn it into a fraction also. So in this next step, when you take the root of the denominator, leave the square root of 10, class, we get a 5 in the denominator. Since you are multiplying the -20 times the square root of 10 over 5, I can now reduce the rational 20, rational 5 to end up with what right here? Back to Brandon.
No, -4.
Times.
Yeah, times the square root of 10.
You get -4 times the square root of 10. Now you'll notice these are not similar radicals, are they? So these two for sure will not combine. I now come to the others and I'm like, well, hopefully 250 either has a 7 in it or a 10 in it. Class, obviously, 10 times 25, where we take the square root of 25. 5. And so we already had a 2. Now we've got a 5 times the square root of 10. This whole thing will reduce down to... And so this one will be able to combine with this one. Well, what about here? Well, obviously, again, class, there's not a 10 in it, but maybe there's a 7? Does 7 go in evenly? No? All right, what square do we see in 128 then? None of my hints are working, so let's just, what do we, 64 times 2, where we'll take the square root of the 64 to get,
8.
so this becomes 8 times the square root of 2. Now again, do they all combine together? No, but at least these two will. So we can combine those, class, to get
6 times the square root of 10.
and then I guess we'll just keep the negative 3 times the square root of 7 and the positive 8 times the square root of 2. Okay, how many got this answer on this problem? Ooh, only Audrey. Questions from the rest of you? Do you see what we should have done now? That's better than the last one. Questions on this? Questions on this? All right, let's take a look at the next problem that you had. Such a great room, apparently. Cube root of 686a minus the cube root of 16a plus the 6th root of 4a squared. And once again, one of these stands out as it ain't got the same index as the rest of them. So that's where I'll prefer to start. What should I do about this 6th root of 4a squared, Genesis?
Change the 4 to 2 squared.
All right, so we have the 6th root of 2 squared a squared
I'm going to take the 2 out of the index on the next one.
to get,
The cube root of 2a.
good, the cube root of 2 to the first a to the first, or just the cube root of 2a. Everything else is already a cube root. This is massive. This is easy. Let's go easy. All right, let's factor up the 16. Since it's a cube root, I do have to factor it. If it were a square root, I just get a 4. But it's a cube root. I got to factor it, Michael, into
You gotta factor in the 8 and 2
8 and 2. We'll take the cube root of the 8.
to get 2.
So we have a negative 2 now, and we'll leave the cube root of the other
2a.
2. And I can't take the cube root of a because 3 doesn't go into 1, so I'll leave the a. And notice, these are like radicals, similar radicals. Now, does that mean the other one will be? No. Okay? But it's worth at least the thought, right? Maybe 10 or 7 goes in. Maybe 10 or 7 goes in. Maybe there's a 2a and something else. So obviously the a is already there. If it were 2, plus what would the other number be? 343. But can you take the cube root of 343? Oh, that is one of our memorized rational roots, class. That root is
7.
7. So it was 7 times the cube root of 2a, and this time they're all similar radicals. So again, 7 minus 2 plus 1, 6, and we'll keep the cube root of the 2a. How many have this answer on the second to last problem on the handout? Okay, question, Abby?
No.
Makes sense now?
Copied the wrong number.
All right, let's take a look at the last one, a little bit of a shorter problem here. We have 10 times the square root of 3/5 plus the square root of 60. And again, I like to get rid of the fraction because at least there it's not as much, I wonder what factors. There's like a definite process to go with. I've got to take the root of the denominator. And Abby, to do that, I got to change the denominator into a
15 over 25.
right, 25, and of course the numerator becomes a 15. At the same time, let's write the 10 class over 1. We can keep the 10 over 1, change this to the square root of 15 class over 5. And since it's multiplication, numerator, denominator cancel, class will end up with
2 times the square root of 15.
2 times the square root of 15. Now, just as this came to a square root of 15, does not mean this has to be a 15 and something else, but it's worth a try. 15 times, oh, there we go, square root of 4 is. So this also becomes a 2 squared root of 15. 2 times the square root of 15 plus 2 times the square root of 15 class gives us 4 times the square root of 15. How many had this answer on the last homework problem? Question, Maddie. All right, questions at all on the handout? Going once on questions, going twice on questions. Gone on questions, put it away. All right, we don't have a whole lot of time. I blame the masked singer. Protect the guilty. Next section in notes. We'll at least get started on this next topic, and that is multiplying radicals. Multiplying radicals. Now you'll recall that way back when we talked about terms and stuff like that, I said you can only add or subtract like terms. So it makes sense we can only add or subtract like or similar radicals. But multiplication had no such restriction. So it is here. To multiply radicals, write this down, they don't have to be similar. To multiply radicals, they do not have to be similar. But they do have to be the same order. So that's the only real requirement. Must be the same order. And that's another way of saying they have to have the same index. A third order radical is a cube root. A fifth order radical is a fifth root, and that kind of thing. So as long as the radicals are the same order, or they have the same index, in other words, they can be multiplied. And in Algebra 1 class, they were always the same order. And it was a beautiful, purposely constructed to be easy world. But this is Algebra 2, isn't it? Yes. So let's talk about how do we get the same order. Write this example in your notes. Suppose we had the fourth root of 3, the square root of 2, and the cube root of 10. Obviously, these are of 3 different orders, aren't they? Follow this through for a bit. I don't need you to do these exact steps, but I want you to watch. If I wrote this dividing exponent by index, I could get 3 to the 1 divided by 4. This could be 2 to the 1 divided by 2, and 10 to the 1 divided by 3. Correct? But I've written the division as fractions. And we know that fractions could have a common denominator. If that's true, then I could have a common index, because all the index is, class, is the denominator of the fractional exponent, right? If my fractions are 1/4, 1/2, 1/3, what's the common denominator, class? 12. Right, this could become 3 to the 3 twelfths, 2 to the 6 twelfths, and 10 to the 4 twelfths, correct? In that case, here's what I want you to do. I want you to write this. This can become the 12th root of 3 cubed, the 12th root of 2 to the 6th, and the 12th root of 10 to the 4th. All I did was I multiplied this exponent by 3, and I multiplied the 1 by 3. 2 by 6, 1 by 6. 3 by 4, 1 by 4. Does that make sense? Basically just multiply numerator and denominator. There's the numerator, there's the denominator, by the same number. 4, 2, and 3 have a common index of 12. And then to simplify, well, what is 3 cubed, class? 27. What is 2 to the 6th?
64.
64. And what is 10 to the 4th? 10,000. Remember, 10 cubed would be 1,000 times another 10 would be 10,000. Now they all have the same order. Does that make sense? Again, I don't usually go through the whole doing the fraction nonsense, but I figure what index do I want? 4, 2, and 3, I want a 12. Multiply the index by something, use that same power there. All right, so let's practice now with actually multiplying radicals. Step number 1, to multiply radicals. Multiply the coefficients. Step 1, multiply the coefficients. Step 1, multiply the coefficients. So for instance, here I have 3 times the square root of 2 times 5 times the square root of 5. I'm going to start by multiplying the coefficients to get, class, 15. Easy first step, right? Second step, multiply the radicands. Second step, multiply the radicands. I have a square root of 2, I have a square root of 5. 2 and 5 multiply to give me a new radicand, class, of 10. Step 3, leave the index alone. You already changed them to have the same order, possibly, or maybe in this case, they started with the same order, but that's already taken care of. So if they already have the same order, leave the index alone. And step 4, reduce at the end if possible. Notice we're not reducing at the beginning. We're reducing at the end. Maybe. In this case, we don't even need to reduce at the end. We're already good to go. It does not reduce. Write this example in your notes. -3 times the cube root of 6 times -7 times the cube root of 20. -3 times the cube root of 6 times -7 times the cube root of 20. Step 1, class, is to multiply the coefficients to get positive 21. Step number 2 is to multiply the Radicand. So my new radicand is going to be 120. Step number 3 is to keep the same index. I had a cube roots before. I'm going to keep the cube root. Step number 4, see if you can reduce. Now there are no rational factors in 10. What about in 120, considering it's a cube root? Are there any rational factors in 120? 8. All right, let's try it. Choose on the calculator. That was 8 times what? 15. Where I can take the cube root of the 8 to get 2 times the 21 that was already out here as the coefficient gives me a new coefficient class of 42 times the cube root of the 15. And there's my answer. Questions on this example? You see how easy it is? Again, the nice thing is instead of reducing everything and then trying to add, you only have to do one reducing and it's at the end of the problem, which I think is very nice. Write this one down. The 4th root of 2 times negative 5 times the cube root of 3. The 4th root of 2 times negative 5 times the cube root of 3. Well, here it is. What's the problem, class?
Different indexes.
Different index, different orders, right? I've got to get the same order. 4 and 3 can both turn into 12. We did this a moment ago. So instead of multiplying the 4th root of 2, it's going to be the 12th root of something. And negative 5 times the 12th root of something. Class, how do I go from a 4th root to a 12th root? What do I multiply the index by? 3. Then I also multiply the exponent by 3. But what was the exponent?
1.
It was a 1. And if you multiply 1 times 3, class, I get 3. So 2 cubed is 8. Do we see how to do that? Let's look at the next one. I go from an index of 3 to an index of 12. Multiply the index by
4.
Also multiply the exponent 1 by 4. But 1 times 4 is 4. And 3 to the 4th power is
81.
81. Now we're ready to multiply. Class, we multiply the coefficients.
-5.
Negative 5. What do I do with the index? Leave it alone. And then I multiply the radicands together. Aren't you glad for calculators? So I guess this is an easy one. 8 times 81?
168.
Ooh.
No. 8.
64.
648. You did the 8 times 1, but you did 8 plus 8 instead of 8 times 8. 648. And the good news is, normally, if you're having to change the indexes, it's not going to reduce. So we're going to stop right there and leave it. If you were curious, you could try raising 2 to the 12th power and see if a 2 to the 12th is in there, but it's not, I promise you. So it just doesn't reduce. And usually if you're having to mess with indexes, it doesn't reduce. We'll stop there. There's no homework tonight, so we'll pick up more with our multiplying radicals tomorrow. Pardon the interruptions of earlier. How many think you did well on your quiz in spite of all the noise? How many at least enjoyed the quiz more? Never mind. All right, well, we'll continue more tomorrow. We do have another quiz coming up tomorrow over those rational roots. Make sure you study for that quiz. When the bell rings, you'll be dismissed.